Right now, as you're watching this, another galaxy is moving toward us. It's called Andromeda, a spiral galaxy larger than our own Milky Way, containing over 1 trillion stars. And every second, it's getting closer, not by a small amount, but at a speed of over 250,000 miles per hour. From where we are today, it looks distant, quiet, almost frozen in place, a faint smudge in the night sky, barely visible to the naked eye. But that stillness is an illusion, because over the next few billion years, that faint glow will grow brighter, larger, until one day it stretches across the entire sky. Stars will shift, gravity will begin to reshape everything around us, and eventually, the Milky Way and Andromeda will collide, not in a single moment, but in a slow, unstoppable process that will completely transform both galaxies. The question is, what does that actually mean for us? What would we see? What would happen to Earth? And could anything survive it? Because this isn't a distant possibility. This has already begun. To understand what's coming, we need to look beyond our own galaxy. The Milky Way is not alone. It's part of a small group of galaxies, bound together by gravity. And among them, one stands out above all the others: Andromeda, the nearest major galaxy to us. At a distance of about 2.5 million light-years, it's the farthest object you can see with the naked eye, a faint, elongated glow in the night sky. But that faint glow hides something enormous. Andromeda is a spiral galaxy, much like the Milky Way, but larger. Its disk stretches wider, and it contains over 1 trillion stars, far more than our own galaxy. At its center lies a supermassive black hole, surrounded by dense regions of stars, gas, and dust. Spiral arms extend outward for tens of thousands of light-years, forming a structure that, from a distance, looks calm and stable. But it isn't, because Andromeda is not just sitting out there in space. It's moving, not in orbit, not drifting past, but heading directly toward us at roughly 250,000 miles per hour. This motion isn't random. It's the result of gravity, the combined pull of both galaxies, slowly drawing them together over time. And unlike most galaxies in the universe, which are moving away from us as space expands, Andromeda is one of the few coming closer, which makes what happens next unavoidable. From where we are today, Andromeda is still far away, but over time, that distance continues to shrink. In about 4 billion years, the first real interaction begins, not as a sudden impact, but as a gradual shift. The outer regions of both galaxies, the vast halos of stars and dark matter surrounding them, will begin to overlap. Gravity starts to take control, pulling on everything inside both systems. Stars drift from their original paths. Gas clouds begin to stretch. The structure of each galaxy starts to distort. This is the beginning of the first pass. Andromeda will move through the Milky Way, continuing forward as both galaxies pull on each other. Enormous tidal forces will draw out long streams of stars, forming extended arcs that reach far into space. But this is not the end of the encounter. After passing through, Andromeda will be slowed by gravity. Over time, both galaxies will begin to fall back toward each other. A second pass follows, then another. Each interaction reshapes them further, pulling stars into new orbits, redistributing gas, and gradually breaking down the original spiral structures. This process continues for billions of years, until eventually, the two galaxies stop separating and begin to merge into one. Long before the galaxies meet, the night sky would begin to change. At first, Andromeda would no longer appear as a faint blur. It would sharpen, revealing structure, a soft, elongated shape stretching slightly wider each century. Over time, that shape grows. What once required dark skies to see becomes visible from anywhere on Earth. A second galaxy, clearly defined, hanging in the distance. Then it keeps expanding. Its spiral arms become visible. Bright regions of stars begin to stand out. A glowing band slowly spreads across the sky. Eventually, Andromeda would appear larger than the full moon, and it wouldn't stop there. As it continues to approach, it would stretch across a significant portion of the sky, a massive, luminous structure visible every night. Then comes the first pass. The sky would lose its familiar patterns. The Milky Way, once a stable band of light, would begin to warp. Long arcs of stars would appear where none existed before, curving across the darkness. The constellations would no longer hold their shape. Some stars would drift apart. Others would cluster in unfamiliar ways. The sky would feel unstable. In certain regions, the number of visible stars could increase dramatically, filling the night with a dense field of distant light. Not brighter like daylight, but more crowded, more complex. A sky that no longer feels fixed, but alive. Despite everything that unfolds on a galactic scale, Earth is unlikely to be destroyed by the collision itself. The reason comes down to distance. Even inside galaxies, stars are separated by enormous gaps, often trillions of miles apart. So when the Milky Way and Andromeda pass through each other, their stars don't crash together. They move past one another. What changes instead is the gravitational structure around them. As both galaxies interact, the paths of stars begin to shift. Some are pulled inward toward the center of the forming system. Others are pushed outward, sent drifting into the outer regions of the new galaxy. Our solar system will be affected by this. The most likely outcome is that the Sun remains intact, carrying Earth along into a new orbit within the merged galaxy. But that orbit may be very different from the one we have now. There is a small chance that a close gravitational encounter with another star could redirect the solar system entirely, pushing it much farther from the galactic center or even ejecting it into intergalactic space. A quiet, isolated path through darkness. So while the collision reshapes the galaxy around us, Earth itself would most likely survive the event. But survival, in this case, doesn't mean safety, because something far closer will decide its fate long before that. Long before the galaxies finish merging, the Sun reaches the end of its stable life. Right now, it burns steadily, converting hydrogen into helium in its core. But over time, that fuel runs out. As the balance inside the Sun begins to change, its core contracts. At the same time, its outer layers expand outward. Slowly, then dramatically, the Sun becomes a red giant. Its size increases many times over, growing large enough to reach deep into the inner solar system. As it expands, the amount of energy reaching Earth rises sharply. The surface heats, the oceans begin to evaporate, the atmosphere starts to break down. Over time, Earth loses the conditions that make it habitable. Eventually, the Sun may expand far enough to engulf the inner planets entirely, including Earth. Even if it doesn't, the result is the same: a planet that can no longer support life. This transformation happens on a timeline that closely overlaps with the galactic collision, which means that by the time the Milky Way and Andromeda fully merge, Earth is no longer the world it once was. After billions of years of interaction, the Milky Way and Andromeda no longer exist as separate galaxies. What remains is a single, newly formed system. The original spiral shapes are gone. The distinct arms that once defined both galaxies have been pulled apart and redistributed, leaving behind a more rounded, less ordered structure, an elliptical galaxy. Stars that once moved in flat, rotating disks now follow a wide range of paths, orbiting in all directions. The new galaxy becomes a vast, glowing sphere of stars, surrounding a dense central region. At its core, another transformation takes place. Both galaxies bring with them a supermassive black hole. As the merger completes, these two objects move closer, eventually forming a single, larger black hole at the center of the new galaxy. For a period of time, as material falls inward, the central region may release large amounts of energy, briefly becoming far more active than before. But this phase doesn't last. Over time, the motion settles, the structure stabilizes, and the new galaxy becomes a long-lasting, stable system. Different from what came before, but no longer changing in the same way. On human timescales, this changes nothing. The sky will remain the same. The stars will hold their place. But far beyond our lifetime, everything is already in motion. The Milky Way is not permanent. Neither is Andromeda. They are part of a universe that is constantly evolving, slowly reshaping itself over billions of years, not through sudden destruction, but through gradual transformation. And one day, long after we're gone, our galaxy will become something entirely new. Join us next time as we explore more mysteries of the universe.